time for dinner in Mumbai, India, because it is 6:30 p.m. Whereas in Berlin, one might be getting ready for an afternoon nap. Time zone is something that we need to handle while doing time series analysis in Pandas. For the purpose of this tutorial, I went to Google Finance and I have downloaded Microsoft stock prices by clicking on historical prices here, supplying your date range, and then clicking on this link. You can download it to this CSV file. I have prices for only few days and I'm concerned with only the closing price. As usual, I'm going to run Jupyter Notebook in my command prompt to launch a notebook environment, and here I have created a new notebook. I imported pandas and then used read CSV call to read the CSV file into this data frame. You can notice that I have a datetime index which I got by supplying this index column argument. Okay, now let's examine the index here. So the index has a data type of date time. Now this date time object is naive date time because it is not time zone aware. There are two kinds of datetime objects in Python in general. Naive datetime, which doesn't have any information of time zone, and time zone aware datetime, which contains information about specific time zone. So how can you convert this naive datetime index into time zone aware datetime index? For that, you can use dataframes tz localize command and supply the time zone as an argument. I know that these stock prices are coming from New York Nasdaq Stock Exchange, so I'm going to use US Eastern Time Zone, and then what I will do is I will type in df index. Here it is still showing the original date time because I did not assign the data frame back. So what I have to do is df equal to df.tz localize, because tz localize will not modify the original data frame. So you have to just assign it to itself. And when I run it, now you can see that I have a US Eastern time zone. Not only that, here you were just seeing 9 o'clock versus here you are seeing 9 o'clock minus 4. Now this minus 4 means US Eastern time zone is 4 hours behind the UTC, or Universal Coordinated Universal Time Zone basically. So we are like 4 hours behind it, and that's why it is showing minus 4. UTC is similar to GMT, which is also known as Greenwich Mean Time. Okay, now let's convert this time zone into Berlin time zone. Okay, so when it was 9 o'clock in US Eastern zone, it was 3 o'clock in the afternoon in Berlin, Germany. So how can you convert this index into Berlin time zone index? Okay, so for that you can use tz convert function, and in the argument you would supply the time zone. So here the time zone is Europe, Berlin, and when you do that, you will notice that here you got 3 o'clock. So for the 9 o'clock here you got a 3 o'clock, and plus 2 indicates that in Berlin it is UTC plus 2 hours. Okay, now how do you know the string that you have to supply for a corresponding time zone? Well, these time zones are coming from pytz module. So if you import from pytz, import all time zones, this has information on all time zones. Okay, so if I just simply print these, it will just show me a list of all the time zones which are available that I can use. Okay, so now I'm going to convert the same data frame into a Mumbai time zone. Okay, so Mumbai, India. For that, I will again use tz convert function and supply the time zone corresponding to Mumbai. Now I don't remember the string that I have to supply for Mumbai, so I will search here. Now I know that it is somewhere in Asia, so this shows all the Asia time zones, and if I scroll down, it has Delhi, Dubai, everything, and I have to go to Mumbai, but looks like it doesn't have Mumbai here. Okay, so somehow Mumbai is not present here, but I know that the time zone in Mumbai is same as time zone in Calcutta, which is another city in India, so I will just use that. So let's go and copy Calcutta's time zone string here, and when you do conversion, you can see that it converted it. Okay, 9 o'clock in New York is 6:30 in India, and it is 5 hour 30-minute ahead of a universal coordinated time zone. Now you can use tz convert on data frames index also. So if instead of doing df.tz convert, you can also do df.index.tz convert, in which case you will assign it to df.index, and that will also have the same effect. Now let's look at how you can use time zones in date range function. Now from our previous tutorial, we know that you can use Pandas date range function to create a date time index. So let's say I'm using 1/1/2017 as my start date, and the periods, I'm giving 10 periods, and my frequency is, let's say, hourly. Okay, and when you create a range like this, what happens is it is creating a naive datetime objects in your datetime index. You can create time zone aware datetime objects by supplying tz argument, where you will supply the time zone. So let's say I'm giving London time zone here, and when you execute it, you can see that the data type of your datetime index is time zone Europe London. Now date range will accept two kind of time zone. This one is using pytz time zone. So we previously printed all the time zone from pytz. This is the list that is available. The other kind of time zone that you can use is called dateutil. So all you have to do is supply dateutil ahead, and that will also create Europe's London time zone, but you can see it looks a little different here. And the main difference between pytz and dateutil is that pytz has all these predefined time zones available in all underscore time zones, versus dateutil will use all the time zones available on your operating system. For the common time zones, they are same as the ones available in pytz. So that's the main difference between dateutil and pytz. I tend to use pytz more, but it is really your choice. Now let's look at some arithmetic between two different time zones. I'm going to create a time series here using these periods. Okay, now I have this time series available, which is S, and it has these numbers starting from 0 to 9, and the frequency of my time series is 30 minutes. Now I'm going to create so I'm going to just convert this time series into a Berlin time zone. Okay, so Europe, Berlin. Okay, I got this error because this guy doesn't have any time zone. If you look at S, this is a naive date time. So instead of using tz convert, I need to use tz localize. And now I got a Berlin time zone. Okay, you can verify that this is a Berlin time zone. Now let's create a Mumbai time zone series. So again, same, use original time series and call tz localize function on it to convert time zone into Mumbai time zone. Now Mumbai doesn't have its own time zone string, so I'm using Calcutta. And here you can see UTC plus 5:30, so this is an Indian time zone. Now I got the Berlin time zone series and Mumbai time zone series. What will happen if I do B plus M? So you can see that here I got NaN values for a couple of these numbers, but then there are these three numbers for which I got some values. Okay, so what it did is it converted both of the individual time series to universal coordinated time zone, basically UTC, and then it performed the math. Okay, and it tried to align the data points. So this is a very good feature in Pandas if you are having two different time zones, and if you want to do arithmetic between them, you can just do it, and internally it will convert everything to UTC, and it should align the dates accurately. Okay, that's all I had for this tutorial. I have a link of this Jupyter notebook below in the video description. I highly recommend that you download it, play with it. Coding is something that you will learn by doing it and not just by watching the video. So I would suggest a more hands-on approach where you do coding as you are watching this tutorial, and when needed you can press a pause button and then you can try things on its